All right, you guys, today you're getting into our basic area of regular polygons. So you did area the other day for shapes like triangles, rectangles, circles, those kind of things. So now we're going to talk about a regular polygon area. So first off, you guys defined this the other day as well, but we're just going to redefine it. A regular polygon is going to be a polygon with all sides congruent. So if you look at these two polygons I have over here, so this one here is a pentagon, and we will call this a regular pentagon. And then here we have a regular hexagon. So since they're regular, all 5 sides here are congruent, and all 6 sides here are congruent. So if this side here is 5, then this means all of the sides around here would be 5. If this side here was 10, then the other sides all the way around would be 10. Okay, so you guys didn't really need to write that part down on the pictures. I just wanted to kind of re-stress to you what regular means. So regular means all sides are going to be congruent. So now we're going to get into the different pieces of a regular polygon, and the first is the radius. So I want you guys to imagine that you have a center point somewhere here, right smack dab in the middle of your polygon here. So the radius is going to be the segment from the center of the polygon to a vertex. Now, a vertex is just a fancy way for me to say corner. Okay, so if you're going from the center here, you could go to any one of these corners, and then this here would be a radius on this pentagon. Now, I chose this corner. I could choose this corner. I could choose this corner, or I could even go to this corner. So notice when I draw these radii from every corner in this pentagon that it forms 1, 2, 3, 4, 5 triangles, and there are 5 sides. All right, hold on. Okay, sorry, I had a little pop-up there happening. I'm not sure what happened there. So I really only am going to stress here about one of the radii, but just keep that in mind. You can draw a radii from every corner, and that when you do that, it creates so many different types of, not so many different types, so many triangles. Now, same thing will happen here with the hexagon. If I go from the center and I draw a radius from the center here to a vertex, I could do that for every single vertex here. I could draw a radius. And I'm sorry, I'm using my iPad. I'm not doing a very good job here. And if you count, it creates 1, 2, 3, 4, 5, 6 triangles. We have 6 triangles for 6 sides. All right, so now I'm going to go ahead and erase this and just leave one of the radii drawn in there, so that way my picture doesn't get too crowded. Actually, I'm going to leave 2 so I can see at least one of the triangles for each of these. So you have a radius here. Okay, so then now we have what we call our central angle. So this is going to be an angle created or formed at the center of the polygon. So this is why I wanted to keep at least one of those triangles in here. Notice that this top angle for both of these triangles here for the pentagon and the hexagon, you have an angle, and it's where the center of the circle is. So this right here and here, this would be my central angle. All right, and then our final vocab word is the apothem, and the apothem is going to be this segment from the center to the side of the polygon. So if you go here to the center of your polygon and you drop this apothem down here, it's going to form a right angle with the side of your polygon. So this is your apothem here. If you go from the center of this down here, you're going to have your apothem here, which we will label as lowercase a. So I'm going to put a lowercase a there so you know what letter we're calling our apothem. Okay. Now notice whenever we dropped that apothem in here that it creates a right triangle here. It creates two right triangles, actually, but you really only need to focus on one of them. So that apothem, whether it's the pentagon, the hexagon, it could be a decagon, whatever type of polygon you have, is going to take that central angle and it's going to cut it in half. And it's going to take the side of your polygon and it's going to cut it in half. So think of the apothem as a length that will bisect the central angle and the side. So it's going to bisect the central angle and the side of the polygon. All right, so what we're going to do is we are going to talk about how you can find the area for a regular polygon. So there are two formulas here that we can use. We will probably use this one a majority of the time, but just know you can use either formula. So you can take 1/2 the A times P, which P stands for perimeter and A stands for apothem. So we, for this one here, A is the length of your apothem, and then P is your perimeter, and A is your area. The other formula here that we will use most of the time is A equals the apothem, so 1/2 A times N times S. N's going to stand for the number of sides, and S is going to stand for the side length. So even though these formulas look different, P here is the N times S. Okay, so NS is equal to the perimeter because all perimeter means is you're adding up all the sides. So if you have a pentagon and you want to find its perimeter, if all the sides are 5, you would do 5 plus 5 plus 5 plus 5 plus 5, which would be the same thing as just taking 5 times 5. Okay, so that's why even though they look like different formulas, they are actually exactly the same. So we use this one most of the time because once you just plug everything into it, you don't have to do N times S first and then the 1/2 times A times N times S. Okay. Another way you will see this written is you can take A times P divided by 2. Here, you could write this as area equals A N S divided by 2. Okay. Either way is going to give you your answer. All right, so we're going to do a quick 2 examples, and then you guys will work on some practice. So today, we are going to give you everything you need in the figure, and all you got to do is plug and chug. And then tomorrow, we are going to take some of the information away, and you'll learn how to find the area that way. So first off here, I have I'm going to write my area formula down. I am going to use this formula here, A equals A times N times S divided by 2. So we just need to figure out what we are going to plug in here. First off, the apothem is a length from the center to the side. It's always a length that forms a right angle with the side. So our RA here is 13.7. Our number of sides, so if you count, you have 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. So N is 9. And then the side length here is 10. So we're going to take 13.7 times 9 times 10, and we're going to divide that by 2. So I'm actually going to go into Desmos and type this in because I'm on my personal computer. So I'm just going to multiply all this out. So if I go here, I'm going to take 13.7 times 9 times 10, and then divide all that by 2, and I get 616.5. And then that would be my area. So 616.5. All right, so go ahead and pause the video, and I want you guys to see if you can work on number 2 on your own, and then when you're done, hit play and check how you did. All right, so for this one here, we're going to take the ANS divided by 2. So your apothem is, again, the length from the center out here to the side, forms a right angle with this side there, so A is 9.6. In here is 5. If you count, you have 1, 2, 3, 4, 5 sides. And the side length is 14. So I'm going to plug all this in. So 9.6 times 5 times 14. Divide that by 2. And let's see what we get. So in Desmos here, I'm going to go 9.6 times 5 times 14, divide all that by 2, and I get 336. So then that's my area, 336. All right, so that is the introduction to area of regular polygons. If you have any questions, please make sure you let us know. But again, just a quick rehash here. You have these different parts to your regular polygon. So R is the radius. Then you have your central angle here in the center, and then you have your apothem, which is the length from the center out here to the side. Today we really only focused on where the apothem is because it's part of our area formula. Tomorrow you're going to utilize that central angle and that radius a lot more. So today you just learned where they are. Tomorrow you're going to learn when they will be useful for area. All right, and if you have any questions, again, please let us know and go ahead and work on your area of regular polygons practice number 1. Have a good day.